The uncertainty of equipment is sometimes stated on the equipment itself, sometimes it's not stated on sometimes you will have to deduce it. The uncertainty indicates the error in that value. So let me just show you. So this is an example of a graduated pipette. So you'll see that here, that's the maximum volume, so it can measure 10 centimeter cube. Okay, and here, what is seen as tolerance here, this plus minus 0.1, this is the uncertainty. Okay, and this is something that I was referring in class. The class of the equipment or the grade of the equipment, twice the tolerance of class A means that is twice less accurate, which means that class A is more accurate than class B. So then you have different types of equipment. You have class A type 1, class A type 2, class B type 1, class B type 2. So as we're going, as the alphabet goes up, so the uncertainty becomes less accurate, and it also indicates, the type will indicate the flow of the liquid in the equipment. So here on any equipment you will see this as the uncertainty plus minus 0.1, which means that when I'm recording 10 centimeter cube with this pipette, it means that the value could be 10 plus minus 0.1, means that it could be 10, it could be 10.1, or it could be 9.9. These are the possible values that it could be. So means that if I'm saying that an equipment has uncertainty of 20 plus minus 0.1, and then I have another one 20 plus minus 0.01, so this is less accurate, so it could be 20.1, or it could be 20, or it could be 19.9. This could be 20.01, it could be 20.00, or it could be 19.99. Okay, so as you can see, the higher this value, the less accurate it is. The smaller this value, the more accurate it is. Now, these values of uncertainty, the values will always be to 1 SF. Always 1 SF. It could be to whatever number of decimal places. DP does not matter here. You could have, so DP does not matter. It could be to any DP, it could be to 10 DPs or 1 DP, doesn't matter, but it should always be 1 SF. So uncertainty is usually indicated by the instrument, like you've seen on that pipette. But if it is not indicated on the equipment, you will have to deduce it. There's 2 ways of doing that. If it is a glassware, then it's half of the smallest division of the instrument. For example, if you have something that has a scale of let's say, so let's say this is 0, 1, okay, so let's say here, so the smallest division that we can read, so this is 1, so means this is 0.1, 0.2, 0.3, 0.4, etc. So smallest division is 0.1, which means that the uncertainty is half of the smallest division. So that would be 0.05. So if I'm reading something, let's say the volume that is being measured here, let's say it's this value. So this would be 0.8. So when I am giving that value, recording it, I will be recording it as 0.8 plus minus 0.05. Now this is 1 dp, so this is 1 SF, so it's good, but it's 2 dp. So my value, the value that I'm using here, should be the same dp here. So then I'm going to add a 0 here, because this has to be to 2 dp. Okay, so whatever value you have here, it will need to be to the same dp as the uncertainty. So it's set here. You can underline it in your handouts. So decimal places for the measurement should be consistent throughout the recording, and it should be the same number of decimal places as the uncertainty of the equipment. So same dp here. Okay. So these are a few examples given. So you'll see that. So this is 3 dp. So I'm recording this as to 3 dp. Again, this is 1, 2, 3, 4 dp. So this is recording to 4 dp. This is to 2 dp. So again, 2 dp. This is to 1 dp, and this is to 1 dp as well. Okay, so dp should match with the SF of the uncertainty. Sorry, the dp should match with the dp of the uncertainty. Yeah, same dp. Okay, so work out these questions now, and then watch the next video for the correction.